hierz und immer stummer, ist jen Wecke selig auf, bringet uns euren Schlummer, meines Lebens Dawn hinauf, verwandelt dann, worin sie schien einen Traum von mir.
We all know that our senses enable us to see what is going around us, to connect with the world. We perceive, we feel, we learn, we explore, we interact, we enjoy. Everything is done through our senses. Sensory processing is the way in which our nervous system manages incoming sensory input. But what does it actually mean? In order to better understand it, we are going to look a bit deeply into our nervous system. I decided to divide the lecture into two aspects: the micro perspective, meaning the sensory processing in the cellular level, and afterwards I will speak about the macro perspective. So let's start. We know that after we feel something, after the stimulus is given, the spatial summation and the temporal summation of the synapse leads the neuron's reaction, whether it's going to be excitated when the stimulus is new or changing or relevant to our attention, or inhibited when the stimulus is boring, redundant, and it's not relevant for our function anymore. As in other neural functions, sensory processing depends on the relative contribution of excitatory or inhibitory synaptic inputs. When excitation exceeds inhibition, we are able to be aroused, to pay attention to stimuli around us, to focus, to explore, to learn. On the other hand, when inhibition is stronger than the excitation, we are able to habituate to a specific stimuli, to put them aside in the background and not in the center of our attention. Now, proper sensory processing means that we have the right amount of excitation and inhibition according to the specific goal of our function. Meaning that we are able to refer to relevant stimuli around us in the right proportion of their modality, location, intensity, duration, and properly modulate it according to the relevance of the stimulus to our function. For example, if we have to listen to the teacher, we will focus on her voice and ignore the sounds around us of the electricity, the computer, the air condition. In SPD, the right amount of excitation inhibition is not always found. SPD represents the inability to process sensory stimuli in a graded manner. Too much excitation or too much inhibition. This directly affects our behavior. The person cannot execute behaviors that are suitable for the characteristics of the sensory stimuli. When excitation is continuously higher, it leads to hypersensitivity or hyperarousability. What does it mean? That I must be alert to the stimuli around me in order to run away from them because they are like pain for me. I cannot bear them. I have to protect myself. This is why SPD is being on the edge. Hypersensitive on one edge and hyposensitive on the other edge. But why is behavior so affected by our sensory stimulation? What explains the unmodulated arousability? The answer is insufficient adaptation and gating. We all know that adaptation is a change over time in responsiveness of sensory systems to a constant stimulus. If we have a change over time to the responsiveness of the sensory systems or our brain to a constant stimuli, then we are open to new stimulations. For example, we can adapt to the cold water in the pool, right? When we get into the pool, it's cold. But after several minutes, we adapt to that. We don't suffer anymore. If we get inside a dark room, in the beginning it's like an overwhelming experience, but after several seconds, we adapt. In SPD, this adaptation is problematic. I will show you a short video. Let's do it from here. Okay. Let's go back. So this sweet baby was exposed to a new stimulus, right? To the lemon taste. He had to feel it. He showed an extreme behavioral response, but after 2 seconds he adapted and he seems happy, right? Emotionally stable, balanced, everything is fine again. In SPD, we don't have this affective adaptation. We have the after sensation effect, mainly in hypersensitivity, when sensation and related behavior responses may linger long after the stimulus is ended. In this picture, you see the little boy leaves his house in the morning into the sunny environment on his way to the school, to the kindergarten, and the overwhelming sunlight causes an avoidance reaction. He covers his eyes and complains for several long minutes that his eyes are aching. So imagine being a mother, taking this kid to the kindergarten while he is crying because of sunlight, that most of other people and children do not suffer from it. So why is behavior so affected by sensory stimuli? What explains the unmodulated arousability? This leads us to another important term called gating. You know these words from neurophysiology? These terms, gating, adaptations, you're familiar with that? Okay. So gating is the brain's ability to inhibit or excitate a specific response. There is like a gatekeeper neuron which influences the transmission of information by either suppressing or facilitating synaptic activity. Why is the gatekeeper so important? Because it's critical to protect our brain, to direct processing resources to important environmental stimuli, to protect the cells from noisy input and ejected errors. It enables the brain to selectively regulate its sensitivity to sensory stimuli. And when it's insufficient, we have a behavior of over-inclusion of irrelevant stimuli into the focus of our attention. But how can we measure sensory gating and adaptation? We usually do it by ERP. You are familiar with the evoke response potentials, the EEG recordings that provide us with the ability to study the relationship between behavior and brain processing in real time. So, for example, Davis studied the gating of children with SPD. And she compared them to typical control children and to adults, also typical adults. And she measured the P300 amplitude. So what was found in their study, you can see it with the yellow star, that while among the adults and the typical children that were exposed to an auditory stimulus, we can see the adaptation and we see the gating, because if the stimulus is redundant, the reaction is also adapted. On the other hand, among children with SPD, we still see the celebration. The wave is still high, although the stimulus is exposed again and again, meaning that these children could not adapt properly to the redundant noise they hear. Their brain was still interested in the stimulus as it was brand new. This interferes with further processing and it creates a mess. What is the important stimulus that I will refer to out of all others? How long and how strong should I refer to it? So this is what people with SPD experience. All stimuli around them are important. They don't have a background. Everything is important and interferes with their attention. This is why people with SPD have difficulty to ignore stimuli, and they show elevated distractibility. Before we discuss specific example of the effects on function in daily life, I would like to talk about the macro level of SPD and refer to another important aspect which I decided to call the sensory cognitive emotional flow. We know that we not only sense our environment, we also perceive it and give it a cognitive and emotional meaning. When you go inside a store and you smell a nice perfume, it reminds you of a specific experience or a person you love, and your emotions are getting stronger, okay? So your memory, for example, your cognitive aspect is connected to this sensory stimulus, and also your emotional response. We can give, many other examples. You want to give an example from your daily life where sensory stimulus arouse your cognition and emotions? Go ahead. Food, of course. This is a great example of cognition and emotions, right? We can taste a soup that reminds us with our grandmother, who we loved so much, or we can be disgusted by a specific smell of the food or taste. And of course, we have many more other examples, but we definitely can say that sensory stimuli not only map our environment, but it significantly contribute to our cognitive and emotional status. Let's go to another video. I hope we can see it from here. Okay, this sweet monkey really liked the tactile stimulation. And we know that tactile stimulation and the smell of the mother is critical for attachment, for example, and for baby's development cognitively and emotionally. So all the sensory information is not just, something that we have to know about our environment. It's really meaningful for our emotional development and ability to socialize and to connect with other people. And indeed, when we talk about the sensory cognitive emotional flow, we know that goal-directed activities require the interaction between emotions, motivation, cognition, sensory, motor circuits. I hope that in your mind you already apply it to psychiatry, because in psychiatry you see all these bugs in emotion, in motor performance, in cognition disorders, and I hope that now you connect it better to the sensory processing abilities. When they are impaired, they enhance all the other disorders in our movement abilities, in our cognitive abilities, metacognitive abilities, etc. So just for example, the cortical basal ganglia thalamo networks contribute to the effective of processing sensory information and its relation to higher order cognitive information that decides whether the stimulus is relevant and whether we should pay attention to it and react to it. Okay. We mentioned before some of the cognitive impacts of SPD, but we also know that behavior includes the integral part of emotion, like we just mentioned. And in SPD, we frequently see stress and emotional liability. We see depression. We see the inability to modulate our emotional responses. So how can we see it in our neurophysiology? Let's talk about the autonomic nervous system. It was reported that among children with SPD, with hyper or hyposensitivity, we have atypical patterns of sympathetic activity expressed in their inability to restore homeostasis or self-regulation after a stressor. And the stressor is a regular stimulus of daily life, something we hear, something we touch, something we see. In the study of Schaff et al. In 2010, they studied children with SPD and compared them to typical controls in the same age range. And they referred to vagal tone variability, which is a marker of the parasympathetic nervous system. We know that if the vagal tone is negative, it means that we regulate our heart rate and we accommodate and adapt to the stimulus. We are not alert anymore. Every time you see or hear a change in your environment, it arouses you, right? It arouses you. Your heart beats a bit quicker, but you relax really fast. Here in these children, it was not so sufficient. You can see it in this graph. The SPD group is the red line, and you see there is a baseline. The gap between the red line and the baseline of the SPD group is much higher and positive than the blue line and the baseline of the controls. You see the heart rate is raised and very fast get lower, as opposed to the SPD group, which is still celebrating. So the vagal tone is insufficient. Another measure is the electrodermal reactivity. Electrodermal reactivity is a measure of skin conductance, which varies with the state of our sweat glands. If we are, under sympathetic activity, we sweat, right? So the EDR is enhanced, while when we are relaxed, we sweat less, so the EDR are reduced. In this picture, you see another study of Sept et al. That measured EDR of children with SPD and typical controls. And you see again the celebration in the SPD group as compared to the relatively relaxed EDR of the typical controls. Okay, in order to better understand the emotional outcomes of SPD, we should refer to the activity of specific brain areas that impact emotion. We know that people with SPD have enhanced anxiety and depression. We also know that they suffer from unmodulated activity of brain areas related to emotion, as the limbic system, or the reticular system, or the hypothalamus and the cortex. And in the clinic, we hear a lot of reports from people with SPD about their elevated anxiety and stress. Here you can find an example of a lady, 44 years old. She suffers from sensory hypersensitivity, and she expresses very well her emotional burden and liability. I'm very sensitive to clothing tags, synthetic fabrics. I can't wear jewelry. When I'm in discomfort with sensation, I can cry. I feel I need to survive, like I don't have borders. My emotional responses are extreme. I am nervous, aggressive. People get scared. Thus, I frequently avoid social environments. And indeed, she lives alone in a quiet settlement, no TV in her apartment. She needs a lot of rest during the day. Many signs that you see, I believe, with the psychiatric patients. In a study I performed with Professor Winnie Dunn, we found that people with elevated trends of sensory hypersensitivity and with low ability to register sensory stimuli suffer from greater anxiety state and trait. State is the anxiety I feel right now. I lecture to you, I don't know you, it's relatively a stressful situation. So probably if you measure my EDR, they will be a bit higher as compared to the situation when I come home and I'm relaxed with my family. And trait anxiety is something in my characteristics, built in. There are people that are more stressed than others, right? It's something that is built in my personality trend, okay? But in both measure, state and trait, these people with sensory hypersensitivity and low ability to register sensory input had higher anxiety levels. Another important factor that may play a role in SPD is the fuel of the brain, meaning neurotransmitters. As psychiatrists, you know that medication depend on changing and modulating the neurotransmitter level and activity in the synapse. So this was also found to be related to sensory processing disorder. However, the reports are really scarce. Very, very few reports that also suggest an unmodulated level or activity of these neurotransmitters. For example, decreased dopamine was found to impair smell discrimination. SPD was found among people with reduced volume of dopamine production areas as basal ganglia. Ritalin, methylphenidate, was found to impact smell sensitivity in children with ADHD. SPD was also related to serotonin unmodulated levels, mainly in people with addiction. So we have some examples that give us a direction to think about, but the study is very limited and we should research it in a more intensive way. But we definitely know that these neurotransmitters have a direct impact on areas that are related to cognitive and emotional responses, such as the corticolimbic system, which is related to the affect, to social interaction, to motivation, to attention, to executive functions, to memory, to learning. All of these functions are known to be negatively affected among people with SPD. Now, after discussing the various possibility of underlying neurophysiological mechanism of SPD, let's go back to the definition of sensory processing disorders, because it refers to the central nervous system, but also to the peripheral nervous system. And what may be found if we study the whole sensory tract of a specific modality, not only the ERP and the central apparatus. So in a study that we recently finished in our lab, we examined the auditory hypersensitivity of individuals with SPD, now we refer to adults, and we measured it from the cochlea to the auditory cortex. The main findings show that overreactivity is indeed found to auditory stimuli in all auditory tract levels, from the cochlea up to the cortex. We found that in the cochlear level, people with SPD have different autoacoustic emission measure. You know what autoacoustic are? Autoacoustic emissions actually reflect the ability of the outer hair cells to monitor incoming auditory input. You know, the cochlear amplifier, okay? The outer hair cells actually amplify the corti organ, okay? So the outer hair cells were found to be much more activated among people with SPD. So we see in the peripheral level that they are different between this group and the typical controls. We also found differences in the brainstem level, which includes the efferent system activation. We found smaller acoustic reflex delivered from these areas, meaning that we have less inhibition. And of course, we found differences in ERP reactions. We found it in the P200, which was different in the SPD group in response to frequency change and in response to intensity change. So, to summarize, dysregulated neural system and related behaviors have functional outcomes. They impair our ability to learn, to interact, to develop skills and self-confidence. And indeed, we see in daily life many restrictions that people with SPD experience in their social life, in their work environment, at home, in the community. And these vicious cycles of discomfort and avoidance limit their ability to learn and to improve their participation in daily life, and they impair their quality of life. This is why it is so important to early screen SPD in the clinic and focus our intervention to this issue as well. I wanted to show you some examples of a daily life situation of a boy with hypersensitivity. He had to take a shower and to wash his hair, and he couldn't bear the water, or of course not the soap, but the water was really a threat. So his mother has to cover his face every time she washed his hair. And only in this way he agreed to take the shower. He protected his face, and this made him to feel a bit calmer. So if we want to take with us some home messages, I hope that you will remember that SPD has neural underlying mechanism. I hope that you will remember that it is really important to investigate the underlying mechanism of SPD using applied research and to bridge between the lab, the ERPs, the electrodes, and real life and behaviors and quality of life. This may support our evidence and best practice, and we should measure benefits of specific intervention like sensory integration or medications that we take. It is really important to elevate the awareness of physicians and health providers as well as of the people themselves that suffer from SPD, their family members, their teachers, their employers, to the phenomenon of sensory processing disorder. And to explain that this is not because they are weird or, have specific problems and they want to make our life harder. No, it's because they really suffer. We have to explore together with the person how his or her unique sensory preferences or profiles may be embedded in daily life. We should think how to use other networks in our brain for enabling sensory modulation, like using cognitive strategies or motor-specific performance. We should use our physical and social environment to optimize the processing of a specific information. For example, to make an adaptation in our environment. If our employee suffers from hypersensitive because of the light, we should change the light angle or the light type. If there are specific noises in the environment, we can locate this employee in a specific quiet environment and enable him a comfortable conditions for working. The same for class. If we have a student or a young child with hypersensitivity, then maybe he should sit in the first line and not, at the end of the class, to hear better and to focus better with the class issues.
Stummer wie er